Am I audible? Anyone there? So, am I audible? Can you see the screen? I think we should start in another couple of minutes. So, in a couple of minutes, we'll start. I think it's time that we start the session. So, as you can see on the screen, today we are going to discuss the numericals of the chapter Human Eye and Colorful World. This chapter is of science chapter for CBSE Class 10 students. Now the date sheet is already out. Now you know the deadline. So you must have started preparation, at least those thoughts they might have started. So to help you people, we've come up with these live sessions. So in this particular live session, we are going to discuss the numericals of this particular chapter. So many times in case of physics, we feel that the concepts are clear, but when the time comes when we have to apply the concepts, it becomes a little tricky. So in this particular session, we are going to solve various numericals, solve the concepts, application of concepts, so that you can do well in your exams. So shall we start going? Okay. So what is the idea, or how are we going to proceed about? As our focus is clear for this session, it is completely numerical based. Here the assumption is that you have done this chapter at least once. So you are familiar with the idea, familiar with the theory. Let's have a sort of quick recap. So in case of the just previous chapter to this chapter is about spherical mirrors and lenses. So we've already discussed about lenses in detail in the previous chapter, and in this particular chapter we sort of learn to use the application of our understanding of lenses. Now we know that human eye itself has a lens in it, and a healthy human being has a healthy lens in his or her eyes. But sometimes due to age or some other problems, we observe defects in the human lens or human eye lens, and it needs certain kind of correction. So what are those defects? The defects are myopia, which is nearsightedness, hypermetropia, which is farsightedness, and presbyopia. Out of these three major defects that we are discussing or we are learning this year, our main focus is on myopia and hypermetropia. Myopia, it is nearsightedness in which the person is not able to view objects at a far distance clearly. And in case of hypermetropia, which is farsightedness, in this case, in this defect, the person is not able to view the objects clearly at a certain or near distance. So we also learnt in this chapter the kinds of lenses that are used to correct these defects. So do you remember which lenses are used for which defect? So for myopia, which lens is used? For myopia, which lens is used? For correction of the defect of myopia, we use concave lens. And if you recall the convention that we use for concave lens, the focal length of concave lens is always negative. Therefore, power of concave lens is always negative. So if you are using spectacles, you might be familiar with the number being negative or positive. So generally people, till they reach the age of 40 or 45, they usually have the defect of myopia. So the power of their spectacles is mostly negative. So let's start. Now a lot of introduction has been done. Now let's start with the simpler questions. So you can see the first question itself on the screen. It reads that if the concave lens of focal length f is equal to 1.5 meter used to restore the proper vision, then what is the power of lens? Do you recall the formula? So do you recall the formula for power of lens? So the formula for power of lens is, P is equal to 1 by f. So P denotes the power of the lens, f is the focal length of the lens. Here the SI unit of power of the lens is diopter, and when we are measuring the power of the lens in diopter, the focal length must be expressed in meter. So you can see here that the focal length is readily given in meter. So what are we supposed to do? So we are supposed to simply substitute the value of focal length in this formula. So we get P is equal to 1 upon 1.5. So I hope you are clear with the idea how do we deal with the decimal numbers when they are at the denominator. So how do we do? Whenever you have a decimal number at the denominator, you are supposed to shift the decimal point to the right. So when you shift the decimal point to the right, you add subsequent number of zeros at the numerator. So this becomes P is equal to, did I miss something? Did I miss something when I started this? Can someone comment on this, upon this? If I miss something here, the sign or something. So if you see, in the introductory speech itself, I mentioned that whenever you have a concave lens, the focal length of the concave lens is always negative. So in this case, so it is always advised that whenever you are solving the physics questions, you must write down the given. And while writing down the given, you should ensure that those physical quantities are expressed in SI unit, they are given appropriate signs. So since this is a concave lens, your focal length has to be negative. So it becomes f is equal to minus 1.5 centimeter. Okay, therefore here also in the formula, it becomes P is equal to 1 upon minus 1.5, which becomes P is equal to minus 10 upon 15. If we reduce this further, it becomes minus 2 by 3. And if we convert it further, we get minus 0.67. What is the SI unit of power of the lens? It is diopter. So since it is the concave lens that is used to restore the proper vision, the defect is myopia. To correct the defect of myopia, concave lens is used. Since it is the concave lens, the focal length must be negative. Since the focal length is negative, power of the lens is also negative. So here in this case, the answer is power of the lens is, here you have power of the lens is 0.67 diopter. Okay, so in this case the answer is power of the lens is 0.67 diopter. So if I didn't show you the division here, since there is 3 at the denominator, the division is of a non-terminating kind of a decimal. So in this case we go for the rounding. So I hope this part is clear. I hope the idea is clear that you must understand the kind of lens that is used. So once you understand the kind of lens that is used, if the focal length should be positive or negative, that must be noted correctly. Then and then only you are going to get the correct answer. So let's move on to the next question. So the next question is, a person having myopic eye use the concave lens for focal length 50 centimeter. What is the power of the lens? So in this case, let's start with writing down the given, because writing down the given many a times solve half of your question. Okay, so writing down given solves half of your question. So here you have given the defect is of myopia. Okay, lens used is of course concave lens. So sometimes they simply mention the defect. That time you must remember that to correct the myopic eye or the myopic defect, the person is using the concave lens. And once you know that it is the concave lens, the focal length of the concave lens is always negative. So focal length f is negative. What is the formula to find the power of the lens? The formula to find the power of the lens is P is equal to 1 upon f, provided the focal length of the lens is expressed in SI unit and SI unit of length is meter. So is the focal length given in meter? Is it expressed in SI unit? No. So in this case, it is always advisable that you convert the focal length in the given itself in SI unit. So this becomes minus 50 centimeter becomes minus 50 upon 100. So whenever you are converting from centimeter to meter, you divide that length by 100. So which is minus 0.5 meter. Okay. So thus you obtain the focal length in meter. Now in solution, you simply have to write down the formula. Okay, you simply have to write down the formula. So the formula is P is equal to power P is equal to 1 upon f. Now substitute the value. 1 upon f is minus 0.5. As I mentioned earlier, whenever you have a decimal number at the denominator, you eliminate that decimal number or you adjust the decimal number. So I'm going to move that decimal number to the right. So the number of places I shift the decimal point to the right, those many number of zeros I add to the numerator. So this becomes, I'm going to shift the decimal point 1 place to the right. So the number or this expression becomes like this, that minus 10 upon 5, which is nothing but minus 2. And what is the SI unit of power? The SI unit of power is diopter, capital D. So in this case, the power of the lens is -2 diopter. What is the power of the lens? It is -2 diopter. Again, you must remember, you should have that correlation fixed in your brain that if it is the myopic eye, lens used is concave lens. If it is the concave lens, the focal length has to be negative. If the focal length is negative, then power of the lens has to be negative. And while we are calculating power of the lens, you must express the focal length in SI unit, that is in meters. Now we move on to the next question. I hope the speed is okay. You are able to follow the discussion. Let's move on. So, next question. Oh, interesting. The far point of a myopic person is 80 centimeter in front of the eye. What is the nature and power of the lens required to correct the problem? Now, what happens is that you must be familiar with the idea of far point and near point of a healthy eye. So, far point of a healthy eye is infinity, whereas near point of a healthy eye is at 25 centimeter. So, whenever a person becomes myopic, that is nearsightedness, that time the far point of a person, it shifts from infinity nearer to the eye. Okay, so the far point shifts from infinity to nearer to the eye. Now in this case, what happens is that, and therefore the person is not able to observe or watch the or see the objects that are at the far away distances. So in this case, what happens is that the object distance in this case is treated as infinity, which is the original far point of the person. And due to the defect, the shifted far point, it is treated as the image distance. So original far point or far point of the healthy eye, which is infinity, is treated as the object distance, whereas the changed far point of that myopic person is treated as the image distance, and using this information you are supposed to solve such kinds of problems. So we are going to write down the given here. So it is always better that you write down the defect as well. So many times what happens is that as you start writing down the given information, many of the related clues, they start popping up in your mind. Okay, so the defect is myopic. So the person is myopic. Tell me, for myopic person, what kind of a lens is used? So for myopic person or myopic defect, what kind of a lens is used? So it is the concave lens. Okay. So original far point. What is the original far point of a non-defective eye? Original far point, which is denoted as the object distance, u is equal to infinity. Oh no, how should I write infinity? So the object distance is u. Okay, then the new far point is treated as the image distance, new far point. So new far point is nothing but that is image distance So how much is it? 80 centimeter. In case of lenses and mirrors, are the signs related to the distances important? If you recall, it is always the case. And if you might remember the convention, which is the Cartesian convention, it states that the objects are always kept to the left of the mirror or the lens. So object is always to the left of the mirror, and therefore object distance is always negative. In case of concave lens, the image is formed in front of the lens, therefore image is also formed to the left of the lens, therefore image distance is also negative. This is a very important point here to be noted. So here it is minus 80 centimeter. Okay, so here I missed to give the sign, so it is minus. Now what is the question? They have asked you to find the or figure out what is the nature and power of the lens required to correct the problem. So as you can see that I have written this down in the given itself, that if the person is myopic, the correction lens or corrective lens to be used is the concave lens. Now to find the power of the lens, you must know the focal length of the lens to be used. And how do we find the focal length? Now you have image distance, you have object distance, you are supposed to use the lens formula. So what is that lens formula? The lens formula is, so you must write using lens formula. What is the lens formula? So the lens formula is 1 by u, 1 by v minus 1 by u is equal to 1 by f. Now substitute the values. So 1 by u is 1 upon minus 80 minus 1 by u is 1 upon minus infinity. Remember that 1 upon infinity is always 0. Therefore, this becomes minus 1 by 80 minus 0 is equal to 1 by f. So you get 1 by f is equal to minus 1 upon 80. Therefore, f is equal to minus 80 centimeter. But did they ask you to find the focal length? No. You can see the question. Question is that you are supposed to find the power of the lens. So what is the formula to find the power of the lens? So formula to find the power of the lens is P is equal to 1 upon f. And at that time the focal length must be expressed in SI unit, which is meter. So do you have focal length expressed in SI unit meter? No. So how do we do that? By means of dividing this by 100. So the focal length becomes minus 0.8 meter. So it becomes minus 0.8 meter. Okay. Now power of the lens is given as P is equal to 1 upon f. So which is 1 upon minus 0.8. So we are going to shift the decimal point one place to the right. So this becomes minus 10 upon 8, which is 5 upon 4. That is minus 5 by 4 is, how much is it? It is minus 1.25 diopter. So power of the lens is minus 1.25 diopter. So the kind of lens that we are supposed to use in case of a myopic person is concave lens, and power of that lens in this particular case should be minus 1.25 diopter. Since it's the concave lens, I'm repeating the same thing. Myopic person, to correct the defect of myopia, we use concave lens. Since it is the concave lens, the focal length is negative. Since focal length is negative, the power of the lens is also negative. Thus we move on to the next question. A short-sighted person. What is meant by short-sighted person? A short-sighted person cannot see clearly beyond 2 meters. Calculate the power of lens required to correct his vision. So what kind of a defect is this? Short-sightedness is nothing but nearsightedness, and the defect is nothing but myopia. Okay. So since the defect is myopia, what kind of a lens should be used? So corrective lens should be the concave lens. The corrective lens should be the concave lens. Okay. Now what is the meaning of this particular information that they have given us? So they have told us that the person cannot clearly see beyond 2 meters. So here they have given us information about the shifted far point of the person. What is the original far point of the healthy eye? It is infinity. So what do we do in this case? So in this case, we say that object distance is nothing but the original far point, which is nothing but minus infinity. I'll write that symbol later. Okay, it is minus infinity. Okay, so minus infinity, and image distance is nothing but the shifted far point. So image distance is nothing but the shifted far point, which is nothing but image distance we denote by v is equal to minus 2 meter. Okay, so since they have given us the distance in SI unit, we are going to continue with SI unit. Now they have asked you to find the power of the lens. So to find the power of the lens, you should recall the formula, which is P is equal to 1 upon F. So that means that we have to find the focal length. So how do we find the focal length? We find the focal length by using lens formula. So what is the lens formula? So the lens formula is 1 by V minus 1 by U is equal to 1 by F. Therefore, 1 by V is 1 upon minus 2 minus 1 by U is 1 upon minus infinity is equal to 1 by F. Just now we discussed that 1 upon infinity is 0. Therefore, we get 1 upon F is equal to minus 1 by 2. Therefore, F is equal to 2 meter. But did they ask us to find the focal length? No. They have asked us to find the power of the lens. So what is the formula for finding the power of the lens? It is P is equal to 1 upon F. Now, while finding out or while calculating power of the lens, what is the requirement? The focal length must be expressed in SI unit. Is that the case here? Answer is yes. Focal length is 2 meter. That is, the focal length is expressed in SI units. So we can use the value as it is. So it is focal length is minus 2 meters. So we have P is equal to 1 upon minus 2. So 1 upon 2 is how much? 0.5. So power of the lens is minus 0.5 diopter. So here the power of the lens to correct the vision is minus 0.5 diopter. Okay, now let's move on to the next question. A myopic person uses specs of power minus 0.5 diopter. What is the distance of far point of his eye? So whenever they mention the myopic person, that defect is myopia, and if they are asking you to find the distance of far point, it means that they are asking you to find the distance of the shifted far point. And how do we denote that shifted far point? Distance of shifted far point? It is nothing but the image distance. Okay. So, and in case of myopic person or the corrective lens, with respect to corrective lens used for the myopic person, what is the object distance? Object distance is the original far point of the healthy eye, which is infinity. Okay, so let's start writing here. So given has a myopic person. So what kind of a lens is used? It is the concave lens. If it is the concave lens, the focal length has to be negative, therefore power has to be negative, therefore we can see that power is negative here. Okay, so object distance U is equal to minus infinity. Okay, now they have given you power of the lens P is equal to minus 0.5 diopter, and they have asked you to find the image distance that is the shifted far point, which is denoted by small v. Okay. Now how can we do this? So you can see that they have given you the power. We have object distance. They have asked us the image distance. So whenever we have the reference of object distance and image distance with respect to a lens, you must use the lens formula, which is 1 by v minus 1 by u is equal to 1 by f. But do we have focal length? No. Has it been provided indirectly? Yes. How? By means of power of lens. Since we have power of lens, we can find the focal length of the lens. So, focal length f is equal to 1 by p. Therefore, f is equal to 1 upon minus 0.5. F is equal to 1 upon minus 0.5. You need to shift the decimal point. So it is one place to the right. So numerator has 1 0 added. So it is minus 10 upon 5, which is nothing but minus 2 meter. Now you have focal length. Now you have object distance. So it is easier to find the image distance using the lens formula, and that will give us the answer of the distance of the shifted far point. So using the lens formula, which is 1 by v minus 1 by u is equal to 1 by f, substitute the values. 1 by v is still unknown. 1 by u is minus infinity is equal to 1 by f is 1 upon minus 2. Therefore, as we know that 1 upon infinity is always 0, so we get 1 by v is equal to minus 1 by 2. Yes. Therefore, v is equal to minus 2 meter. Okay. So it is minus 2 meter. Or here when they are asking about the shifted far point, it is, we don't give the sign, so it is in centimeter, it is 200 centimeter. Okay, it is 200 centimeter. Now let's move on to the next question. The far point of a myopic person is 150 centimeter in front of the eye. What information has been provided? Whenever they mention that the defect is the myopia, and then they give you the far point, then it is the shifted far point, and shifted far point is denoted by means of image distance v. Remember, in case of the concave lens, image distance is always negative. Okay. So, and in case of myopia, what is the object distance? It is infinity. So we have u is equal to minus infinity, v is equal to minus 150 centimeter. Okay. Now they have asked you to find the focal length and the power of the lens. Okay, power of the lens. Okay. So to find the focal length, which formula do we use? We use the formula of lens. So lens formula is 1 by v minus 1 by u is equal to 1 by f. Substitute the values. 1 by v is 1 upon minus 150 minus 1 by u is minus infinity is equal to 1 by f. As I mentioned earlier, 1 by infinity or minus infinity is always 0. So the given expression becomes minus 1 by 50 is equal to 1 by f. So taking reciprocal on both sides, we get f is equal to minus 150 centimeter. Okay, it is minus 150 centimeter. Now you have obtained the focal length of the lens required. So what kind of a lens is used in case of myopia? In case of myopia, the kind of lens is used is concave lens. So, and concave lens has the negative focal length. So, f is equal to minus 150 centimeter. Now to find the power of the lens, which formula do we use? P is equal to 1 upon f. But what is the prerequisite to use this formula? The focal length must be expressed in SI units. So you should convert centimeter to meter. So 150 centimeter is nothing but 1.5 meter. Distance in centimeter is divided by 100 to convert it into meter. Therefore, minus 150 centimeter becomes minus 1.5 meter. Now we substitute that value here. So this becomes 1 upon minus 1.5. We have to eliminate the decimal point at the denominator. Therefore, we add 1 0 at the numerator. Since we are shifting the decimal point one place to the right, this becomes minus 10 upon 15. Can we reduce this further? Yes. So power is minus 2 by 3. Upon division, we get power of the lens as minus 0.67. What is the unit of power of the lens? It is diopter, denoted by capital D. Okay, it is diopter, which is denoted by capital D. Therefore, focal length of the lens required is minus 150 centimeter or minus 1.5 meter, and power of the lens is minus 0.67 diopter. And the type of lens that we have used here, or we have to use here, is the concave lens. Let's move on to the next question. So, what kind of questions are we doing here? Right now we are completely focusing on the questions which are based on the defect myopia. So since we are concentrating on myopia, the kind of lens that we are using is concave lens. Since we are using concave lens, how is its focal length? It has to be negative. Since focal length is negative, how should be the power? It has to be negative. Okay, so we come to the next of this particular section. A person wears eyeglass of focal length 70 centimeter. What is the far point of the person? So here you can see that they haven't mentioned about the defect of the person. They haven't mentioned about the kind of lens that is used. Then how are we supposed to deduce the type of defect or type of lens that is used? By means of this information. Far point of the person. So whenever there is a mention of far point of the person, it means that we are talking about the defect myopia or nearsightedness. Since it is the myopia, what kind of a lens, corrective lens used? The corrective lens that is used is the concave lens, and focal length of a concave lens is always negative. So the defect is myopia. The defect is myopia, and the corrective lens used is concave lens. Okay, this information is very much important. You should be able to deduce this information, okay, from the question. Now, since it is the concave lens, we get f is equal to focal length has to be negative, so focal length is minus 70 centimeter. Now when they are asking you about the far point of the person who's wearing corrective lenses, so this far point is nothing but the shifted far point. And shifted far point is denoted by the image distance v. So for us to find is image distance v, and the object distance in case of myopia is always the far point of the healthy eye, which is infinity. So object distance u is equal to minus infinity. The object is always kept to the left of the mirror or the lens, and by Cartesian convention, any distance to the left of the mirror or lens is always taken to be negative. The image distance is also negative, so we have to find the image distance, that is the far point. So we get this as the question mark. Now, as you can see, once we write down the given information, you can see that there are three quantities that are involved here. First is focal length, object distance, image distance. So with respect to lens, these three quantities are involved. That means that we have to use the formula which is of lens formula. So what is the lens formula? The lens formula is 1 by V minus 1 by U is equal to 1 by F. Substitute the values. 1 by V is unknown. Minus 1 by U is 1 upon minus infinity. 1 upon positive infinity or negative infinity, it is always the 0. The answer is 0. So we get 1 by V minus 0 is 1 by V itself. So 1 by V is equal to minus 1 by 70. Taking reciprocal on both sides, we get V is equal to minus 70 centimeter. Therefore, the far point of the myopic person is 70 centimeter in front of his eyes. Okay, the far point of the myopic person is at 70 centimeter in front of his eyes. Okay, so this is the answer of this question. Let's move on to the next question. Don't you wonder, aren't you wondering that are we going to discuss only the questions related to myopia? No, that is not the case. We are going to discuss the questions related to hypermetropia as well. So here they are coming. The blank slide, no. Here they are coming. Okay, so if your eyeglasses have focal length 60 centimeter, then what is your near point? Here again you can observe that they haven't mentioned the defect. They haven't mentioned anything about the lens that they have used. Then how are we supposed to deduce the kind of defect or the kind of lens, corrective lens that is used? So here you are supposed to go through the information, given information. So here they are mentioning about the near point. So always remember, the near point is mentioned with respect to the defect hypermetropia. Hypermetropia is farsightedness, okay, where the person is able to see objects at a far distance clearly, but the objects at the closer distance they are not able to see clearly. So to correct the farsightedness or the defect hypermetropia, what kind of a lens is used? It is always the convex lens. And as per the convention, how is the focal length of the convex lens? The focal length of the convex lens is always positive. Okay, so let's start. So the defect is the hypermetropia. Okay, and the corrective lens used is concave lens. Concave, is it? No, it is convex lens. For last 7 questions we had been using concave lens only, so I simply had that in mind and wrote it down. But as I mentioned earlier, it is the defect is, since they have mentioned about the near point, the defect is hypermetropia, and therefore the corrective lens used has to be the convex lens. Since it is the convex lens, the focal length has to be positive. Therefore we'll start writing down. So you have F is equal to plus 60 centimeter. Now the interesting part comes. So when we are talking about the hypermetropia, we should be knowing the near point of the healthy eye. I'm repeating myself. When we are talking about hypermetropia, we should be knowing the near point of the healthy eye. So how much is it? Anyone? How much is it? The near point of the healthy eye is at 25 centimeter in front of the eye. Okay, and in case of hypermetropia, near point of the healthy eye is treated as the object distance. And I'm repeating myself again. By means of Cartesian convention, the object is always kept to the left of the mirror or the lens, and any distance to the left of the mirror or the lens is taken to be negative. Therefore, here object distance, which will be 25 centimeter, will be treated to be negative. So here we have object distance is equal to minus 25 centimeter. Now V is the shifted near point. V is the shifted near point. Now we have to find the near point of the defective person. So we have to find the V. So here the three quantities are involved: focal length, object distance, image distance. When there are U, V and F involved, which formula do we use? We use the lens formula. What is the lens formula? Lens formula is 1 by V minus 1 by U is equal to 1 by F. Substitute the values. 1 by V, we don't know yet, minus 1 upon minus 25 is equal to 1 by 60. Since it's the convex lens, the focal length is positive. So this becomes 1 by V plus 1 by 25 is equal to 1 by 60. Therefore 1 by V is equal to 1 by 60 minus 1 by 25. You should know the LCM of 60 and 25. It is actually 300. So we get 5 minus 12 upon 300. Therefore 1 by V is equal to minus 7 by 300. To find the value of V, we have to take reciprocal. So V is equal to minus 300 upon 7. So it is minus 42.6. It is 42.6, no, isn't it? 42.8 centimeter. So the near point of that person is at 42.8 centimeter in front of the eye. Since again the image distance or near point is to the left of the lens, we have obtained the distance to be negative. Now we must move on to the next question. We are lagging a little behind the schedule. A person suffering from farsightedness. So what kind of a defect it is? Hypermetropia. Kind of lens used is convex lens. Since it's the convex lens, focal length should be positive. So we have F is equal to plus 50 centimeter. They have asked you to find the near point, shifted near point of the eye. So that is, they have asked you to find phi. So whenever the defect is hypermetropia or farsightedness, that time the object distance is nothing but the near point of the healthy eye, which is at 25 centimeter in front of the eye. So since the distance is measured to the left of the eye or the lens, it is taken to be negative. So it is minus 25 centimeter. We use the lens formula. 1 by V minus 1 by U is equal to 1 by F. So substitute the values. V is yet unknown. So 1 by V minus 1 by minus 25 is equal to 1 by 50. So minus minus becomes plus. 1 by V plus 1 by 25 is equal to 1 by 50. So we get 1 by V is equal to 1 by 50 minus 1 by 25. So the LCM is 50. Therefore, we get 1 by V is equal to 1 minus 2 upon 50, that is minus 1 upon 50 minus 1 upon 50. To get the value of V, we take the reciprocal on both sides. So V is 50 centimeter. So what is the distance of the near point? The distance of the near point is 50 centimeter in front of the eye. Since the distance is to the left of the eye or the lens, it is negative. Okay. Let's move on to the next question. The near point of a hypermetropic eye is at 75 centimeter from the eye. Okay. So they have given you the defect, they have given you the shifted near point. So shifted near point is nothing but V, and since it is to the left of the lens, it is taken as minus 75 centimeter. In case of hypermetropia, what is the object distance? Object distance is the near point of the healthy eye, which is minus 25 centimeter. Oops. What is the lens? What is the power of the lens required to enable him to read clearly a book held at 25 centimeter from the eye? So here they have actually given you the object distance, and which is coinciding with the near point of the healthy eye. Now they are asking you to find the power of the lens. To find the power of the lens, you must find the focal length first, and then you can find the power of the lens. Okay, so power of the lens. So which formula do we use? Lens formula. 1 by V minus 1 by U is equal to 1 by F. So 1 by V is 1 upon minus 75 minus 1 by minus 25 is equal to 1 by F. It is always advisable that you solve the sign, this part. You must solve the sign here. So minus 1 by 75 plus 1 by 25 is equal to 1 by F. You take the you make the denominator same. So you get minus 1 plus 3 upon 75 is equal to 1 by F. So you get 2 upon 75 is equal to 1 by F. So you get F is equal to 75 by 2 centimeter. But they have asked you to find the power, isn't it? So P is equal to, but is the focal length expressed in meter? No. So to express it in meter, you divide the given number by 100. So this becomes 75 upon 200 meter. Is there any reduction possible? Yes. 3 upon 8. I have divided both numerator and denominator by 25. So focal length is 3 upon 8 meter. So power is equal to 1 by F. So which is 1 by 3 upon 8. So I have ensured that while calculating power of the lens, I have converted the focal length into meter. So 1 upon 3 upon 8 is nothing but 8 upon 3, which is nothing but plus 2.67 diopter. Since the defect is hypermetropia, lens used is convex lens. Since it is the convex lens, the focal length has to be positive. Therefore, power of the lens has to be positive. Let's move on to the next question. A person wants to read a book placed at 20 centimeters. So here they have directly given you the object distance. Okay. So object distance is U. Object is always kept to the left of the eye or left of the lens. So it has to be negative. They have given you the shifted far near point, which is at 30 centimeter in front of the lens or eye or to the left of the lens. Therefore, it is minus 30 centimeter. They have asked you to find the power of the lens. To find the power of the lens, you must find the focal length of the lens. So for that, we use the lens formula. 1 by V minus 1 by U is equal to 1 by F. So 1 by minus 30 minus 1 by minus 20 is equal to 1 by F. So minus 1 by 30. You must solve this sign first. It always simplifies the calculations. I'm going to make the denominator same. So for the denominator, the LCM is 60. So minus 2 plus 3 by 60 is equal to 1 by f. So 1 by f is equal to 1 by 60. For focal length, we take the reciprocal. So f is equal to 60 centimeter. But to calculate power, you have to divide it into, or you have to convert into meters. So it is 0.6 meter. So power P is equal to 1 by F. So which is 1 upon 0.6, which is, so shift the decimal point, 10 upon 6. That is nothing but 5 by 3. 5 by 3 will be plus 1.67 diopter. So the power of this lens is plus 1.67 diopters. Since the defect is hypermetropia, lens used is convex lens, focal length is positive, power of the lens is positive. I think we'll have to skip some of the questions. This is somewhat similar to what we did in the earlier question. So actually, if you see, this is a kind of mixture. A certain person has minimum distance of distinct vision of 150 centimeter and he wishes to read at a distance of 25 centimeters. So you have object distance is minus 25 centimeter. Image distance is minus 150 centimeter. So you can see that when they are talking about minimum distance, it is about the near point. Therefore, the defect is hypermetropia. The lens that should be used is the convex lens. So focal length has to be positive and power of the lens should also be positive. I hope that you will be able to solve this question the way we solved the earlier question using the lens formula. Okay. Let's move on to the next question. In case of any difficulty, doubt, you can reach me through the chat. I will definitely respond you and I can provide you the detailed solution if required. The near point of a hypermetropic eye is 1 meter. So they have mentioned that it is the hypermetropic eye. So near point, shifted near point is always the image distance. So it is minus 1 meter. Okay. So in this case, assume the near point of the normal eye as 25 centimeters. So it will be minus 25 centimeter, but both the distances should be in the same form and we have to calculate the power of the lens. So I'm going to convert this into meter. So U is 0.25 meter. So here you can calculate focal length by 1 by F is equal to 1 by V minus 1 by U. That is the lens formula. Once you find out by substituting these values, once you find out focal length, you can find the power, which is P is equal to 1 upon F. Remember, since it is the convex lens, focal length will be positive, power of the lens will also be positive. We've almost completed 1 hour. I think some other questions you can definitely. Remaining questions, I think I'll post them in the offline video. Okay, I can definitely share the solutions of the remaining questions. There were 3 more questions to be completed, but looking at the time constraint, we are going to end the class here itself. In case you find any difficulty in solving these questions, I'm very much reachable over YouTube. You can ping me on my blog as well. I will share the link of my blog there. So keep studying, keep practicing, do well in your exams. So it's time to say bye-bye for the time being. We'll meet in the next session. Do let me know what next would you like to do. I'm definitely reachable on the chats here. Till then,